converter station of 6 pulse converter bridge. This conversion from AC to DC rectification or rectifier station and from DC to AC inverter station are performed. Listen carefully. A point-to-point transmission required two converter stations. The role of rectifier and inverter station can be reversed, that means resulting in power reversal by suitable converter control. Then this converter control can adopted for two kind of pulses. One is 6 pulse converter bridge wall, another one is 12 pulse converter units per pole. The various components of a converter station are discussed on this 6 pulse and 12 pulse converter units per pole. Come, let's go with 6 pulse converter bridge wall. This is usually consists of 6 three-phase converter bridges connected in series to form a 6 pulse converter unit. The total number of valves in such a unit are 6. The valve can be packaged as single valve, a double valve, or a different kind of quadrille valve. Each valve used to switch in a segment of an AC voltage waveform. The converter is fed by converter transforms connected in star to star and star to delta arrangements. The valves are cooled by air, oil, water or freon. The liquid cooling using deionized water is more effective or efficient and results in the reduction of station losses. The ratings of a valve groups are limited more by the permissible short circuit current than steady state load requirements. The design of valve is based on the modular concept where each module contains a limited number of series connected thyristor level. The valve firing signals are generated in the converter control at ground potential and are transmitted to each thyristor in the valve through a fiber optic light guide system. The light signal received at the thyristor level is converted to an electrical signal using gate drive amplifiers with pulse transformer. Then the valves are protected using snubber circuit, protective firing and gapless surge arresters. Some of the details of the control and protection of thyristor valve are discussed laterly. Then let's go with 12 pulse converter bridge valve. Same like the above explanation, because in the above condition we had been seen 6 pulse converter session. Here we have to use 12 pulse converter valve or converter pulses. These usually consist of two three-phase converter bridges connected in series to form a 12 pulse converter unit. The total number of valves in such a unit are 12. The valves can be packaged as single valve, double valve or quarter valve arrangements. Each valve is used to switch in a segment of an AC voltage waveform. Remaining conditions or remaining explanation are same like the above explanation of 6 pulse converter. So no need to explain again the 12 pulse converter. So come, let's go with the HVDC thyristor valve of 12 pulse converter. This valve represent under the control of 12 pulse converter bridge. So again we have to look a HVDC thyristor valve 2 than HVDC thyristor valve 1. This diagram meant the switches of pulses on the 12 pulse circuit diagram. So this thyristor valve 1 and thyristor valve 2 represent according the diagram of 12 pulse converter. So already I had been given more explanation for that for the 12 pulse converter. So no need to explain further. This is HVDC converter, transformer and filter. Now I have more response to convey the HVDC converter transformer because the converter transformer can have different configurations. 3 phase 2 winding, single phase 3 winding, single phase 2 winding. The valve side windings are connected in star and delta with neutral point ungrounded. On the AC side, the transformers are connected in parallel with neutral grounded. The leakage reactance of the transformer is chosen to limit the short circuit current through any valve. The converter transformers are designed to withstand DC voltage stressors and increased eddy current losses due to harmonic current. One problem that can arise is due to the DC magnetization of the core due to asymmetric firing of valves. In back-to-back links, I taught the earlier classes in back-to-back links which are designed for low DC voltage levels. An extended delta configuration can result in identical transforms being used in 12 pulse converter. This results in the reduction of the spare capacity required. However, the performance of extended delta transforms in practice is still to be tested. Then AC filters. Yes, AC filters. There are three types of filters are used. One is AC filters, DC filters, high frequency filters. These three filters are very important filter to reduce the unwanted harmonics and unwanted noise on the converter side. Let us see the first one of AC filters. These are positive circuits used to provide low impedance shunt path for AC harmonic current. Both tuned and damped filter arrangements are used in the AC filter. Then second one is DC filters. These are similar to AC filters and are used for the filtering of DC harmonics. Then third one is high frequency filters. These are connected between the converter transformer, what I told to you all in the previous slide, that converter transformer and the station AC bus to suppress any high frequency current. Sometimes such filters are provided and high voltage DC bus connected between the DC filter and DC line and also on the neutral side. Then this transient period, it has some reactive power source also, so we must consider and reduce that reactive power losses. So converter station require reactive power supply that is dependent on the active power loading about 50 to 60 of the 60% of the active power. Fortunately, part of this reactive power requirement is provided by AC filters. In addition, shunt capacitor, synchronous condenser and static VR systems are used depending on the speed of control desired. This is reactive power source. Next, we have to see the smoothing reactor. A sufficiently large series reactor is used on DC side to smooth DC current and also for protection. The reactor is designed as a linear reactor and is connected on the line side, neutral side, or at intermediate location. Then a DC switchgear. This is usually a modified AC equipment used to interrupt small DC current, employed as disconnecting switches. DC breakers or metallic return transfer breakers. That metallic return transfer breakers called MRTE or MRTB are used if required for interruption of rated load current. In addition to the equipment described above, a switchgear and associated equipment for protection and measurement are also part of the converter station. Okay, this is most preferable converter station of converter transformer, AC filter. Above the explanation, we had been seeing 12 pulse converter and 6 pulse converter bridge. Finally, what are the filtration having in the AC filter? Then we have to look the another topic of bipole HVDC modes of operation.